This is going over geometry homework page 657. Let's get going here. We've got 3, 4, 5, 6, 7, 8, 9, 10, and 11. Here we go. First of all, find the measure of the red arc or chord in circle C. Well, we've got an arc here. We've got a red arc. Well, here's the idea on this. First of all, hey, if that's 75 degrees, vertical angles, 75 degrees. Hey, what was one of the big things? We said it right up in here. Here we go. Yeah, look at the bottom. An arc is equal to its central angle. An arc is equal to its central angle. So, boom, we got 75 degrees. There it is, from there to there. That's not a distance. It's the number of degrees of the arc. Boom, there's our answer on that one. Okay, let's keep on going here. This time, again, it's an arc. Okay, what do we got here? Well, look at this. Hey, we got 128. Here's what I want to figure out. Think about this. Look at these two chords. They're both the same distance. They're 34, whatever units. They're 34 units long. That means that these two arcs, right here, these two arcs are exactly the same. The red one and the purple one are exactly the same because the chords are exactly the same length. Well, let's figure out this arc right here. There it is. Look, I already know this is 128. The whole circle is 360. So let's do it right here. Let me go in green. Okay. 360 minus 128. Let's see what we got. That's going to be a 10. That's going to be a 5. Okay. We got a 2 there. 5 minus 2 is 3. 3 minus 1 is 2. There it is. That's 232 degrees for that whole thing. Well, what do we do to it? Yeah, we cut it in half. 232. There we go. Half of 232. 116. Yeah, there we go. We got 116 degrees for this one, for the red one. And we got 116 degrees for this one. Boom. Our answer, 116. That's what they wanted. The red arc on that one. How about this one? Okay. This right here. It's not really a chord. It's part of a chord. Well, here's the idea. This right here is the radius. And look at it. It's perpendicular to that whole chord. Well, what do we say in the notes? If the radius or any line coming from the center, radius, diameter, even part of the radius, if it's perpendicular, that's the key. If it's perpendicular to that blue chord, then what does it do? It cuts it in half. 8 here, done with the problem. Answer is 8. Okay. How about this one? Hey, here's another one. Here's another one. There it is. There's the radius. There's the radius right there. It is perpendicular to that chord. So what does it do to it? Yeah, it cuts it in half. Here it is. Hey, 4x has to equal 3x plus 7. There it is. Minus a 3x here, minus a 3x here. 1x equals 7. Boom, done. Okay, 6, 7. Here's the idea. Well, what do we see here? Do we see something similar? We sure do. There's the radius. Look at that. It's perpendicular. The radius is perpendicular to that chord. What does it do then? Yep, it cuts it in half. There we go. That part equals that part. Let's go do that. Now it's algebra. 2x plus 9 equals 5x minus 6. I'll tell you what, I'm moving the x's to the right. Minus 2x, minus 2x. Okay, 9 equals 3x minus 6. Let's move the 6. Add 6 here. Add 6. What do we got? 15? 15 is 3x. Divide by a 3. Divide by a 3. 3 goes in there. 5. 5 equals x. What are we going to pick? Boom, stars. There we go. Okay, what do we got? 8. Okay, now take a look. All 4 of these are the radiuses. They're all the radiuses. Well, what do you know about all the radiuses? In any circle, all the radiuses are equal. Okay, there's our equation. 6x plus 9 equals 8x minus 13. Well, let's go minus a 6x. Minus a 6x. Okay, good. We got 9 left equals 2x minus 13. Let's add 13. Let's add 13. Okay, what's that going to be? 22? 22 equals 2x. Divide by a 2, divide by a 2. What's that? 11 equals our x. Looks like we're done. I don't know. Let's go right here. Boom. Always like the tie-dye. Okay, next one, 9. Okay, now, these 2 chords, take a look at them. What do we know about those 2 chords? They're the same distance from the center. Take a look right here. They're the same distance from the center. So what does that know? What do we know about those 2 green chords? If they're the same distance from the center, then they are congruent. 18 has to be the same as 5x minus 7. Here we go. Let's go add 7 here. Add 7 here. Looks like we got a 25 equals a 5x. Divide by 5. Divide by 5. There it is. 5 equals x. Boom, done. Okay, now, same idea. Same idea. Okay, here it is. Here's these 2. Well, right now we'll call them green. They're green chords. Look at that in the center. They are the same distance from the center. Then they're equal to each other. Here's one way to do it. If this is 3x plus 2, so is this. 3x plus 2. Okay, now, what's the whole chord gonna be then? What do you got? You got 3x plus 2 and another 3x plus 2. Put them together. Yeah, I got 6x plus 4. That's got to equal 22. Let's set it up then. 6x plus 4 has to equal 22 minus a 4 here, minus a 4 here. Gone, gone. Okay, 6x equals, what's that, 18. Divide by 6, divide by 6. X equals 3. That's all they wanted. They just want the variable on this. Boom, there you go. Okay, last problem. Yeah, here it is. Okay. Well, look at this. This time, these 2 chords, they're both 15. They're both exactly the same length. Well, if the 2 chords in the circle are exactly the same length, then what do you know? They are the same distance from the center. That's the idea. If they're the same distance from the center, they're the same length. If they're the same length, then they're the same distance from the center. Here's our equation right here. This guy equals that. Let's do it. 4x plus 1 equals x plus 8. Let's do it. Okay. What do we got here? We got minus an x, minus an x. Okay, nice. 3x plus 1 equals 8. Okay, minus 1, minus 1. Okay, that looks good. 3x equals 7. Divide by 3, divide by 3. X equals 7 over 3. Can you get a fraction? You can, as long as it works in your problem. Okay, looking good. We set them up, subtracted an x, good. We got 3x, great. Subtracted a 1, we got 7. We're looking good. That's it. That's going over homework, page 657.